We're going to start on the 2013 packet, and I'm going to start on number 2. All right, so it says suppose that P of X equals X to the third minus 2X squared plus 13X plus K. So they don't give you that very last number, but they do tell you that the remainder of the division by X plus 1 is -8. So remember, if we're going to divide on this one, I would use synthetic division. Okay, so it makes it a lot easier. Don't use long division, whatever. So remember, synthetic is the backwards box. If we're dividing by X plus 1, what goes in the box? -1. Remember, we changed the sign. If it's equal to, we leave the sign. If it's a function or like in parentheses, you change the sign. Then remember, we write the numbers all the way across. So it's 1x cubed -2x squared, just the numbers, nothing else. A 13x. And then we don't have that last number, it's a k. So we're going to write that k. Once we do this, you'll see that it's fairly easy. It's going to look crazy for a minute, but it's really easy. Skip a line, draw a line. We're going to bring this 1 down, and we're going to multiply by -1. We get -1. We're going to add them. We get -3 times the box is +3 plus 13 is 16 times -1 is -16. Now that's as far as we can go for right now, but it told you that the remainder was -8. So that 8 goes right here, -8. This gives you an equation. Right here is your equation. So we have k minus 16 equals -8. We're going to add 16 to both sides, and we get +8. So that k is 8. That's not what it asked for, though. Okay, understand that. You see that that answer is on there. Make sure that you're asking, all right? What's the remainder of the division by X minus 1? So now we have to do the same thing, but we're doing it by X minus 1. So what goes in the box? 1. We're doing the same function, which was a 1x cubed -2x squared, a 13x, but we found out that k was 8. Bring down the 1. 1 times 1 is 1. Add that up, we get -1 times 1 is -1. 13 minus 1 is 12. Times 1 is 12. Plus 8 is 20. So your answer is going to be B. Okay. So if you put the answer B, you were doing it correctly, but you just didn't finish the problem. That's it. Okay. So make sure that you answer the question that they asked. Any question on number 2? Not a hard question, just one of those you have to trudge through. Is that good? All right. Hold on, I got 2 different packets here. All right, let's look at number 5. Number 5, I would use graph paper 4. We just went over this not too long ago. So it says, which is an equation of a parabola that has a directrix of y equals -5 and a focus at 2, -1. So it says a directrix at y equals -5, 1, 2, 3, 4, 5. A focus at 2, -1. What information does that give us? One super important part that it gives us. The what? Okay, we do know it's U-shaped, so that's one of the other ones. What else does it give us? So if it's U-shaped, that means all these are going to be positive. So that doesn't help us to follow on that one. But you are correct. If there would have been a negative, we could have eliminated it. What else does it give you? Are you sure? Why? I'm just questioning you. You're not. What'd you just say though? The what? Where is the vertex? Where? Not 0, -5. That's a y intercept. For the, it's just the focus vertex. Exactly between it, right? Remember, that's the one key thing that we can get from here. Exactly between it is the vertex. That vertex is at 2, 1, 2, 3, -3. 2, -3. Everybody good so far? 2, -3. So when we put it inside, remember our x is going to change, so it can't be a +2. So that eliminates those. It'll have to be a -2, so that's good. And then your vertex has a -3. So the only one it could be is C. So the only thing you needed from this was the vertex. To get the number in front, they would have had to give you another piece of information, like another coordinate that it passes through or something like that, okay? Any questions on number 5? All right, let's keep going. All right, so I don't teach you guys this, but I did. I mentioned it to you. Do you remember when we worked on arc length? You don't have to remember the formula or anything, but when I mentioned arc length, I told you there was another formula that looked just like arc length. So I'm going to throw the arc length formula out here for you, because I think we use it at some point within these packets. Was your degree over 360 equals your arc length over, it's part of the outside. So we did 2 pi r, or we did diameter times pi. So whichever formula we use, I think we use 2 pi r. All right, so you guys remember that one. So this one is area of a sector, and that just means we're finding the area of a slice of a pizza. And it is almost the exact same formula. Okay, let me rephrase this one more time. Arc length, that arc is part of the outside. So the formula for the outside of the circle is 2 pi r. Does everybody understand that? This is an area of the circle, part of the area of the circle. So this is the sector area over pi r squared, because the area of a circle is pi r squared. So understand that those formulas are pretty much the same. It's just what is it part of? The arc length is part of the outside. The outside is the circumference. This is part of the area. So the area is pi r squared. All right, but so the difference in this one is we actually have just the crust of the pizza. Okay, so if I just have the crust left over, literally talking about eating pizza, if I just have the crust left over, what did I do? Yeah, I just ate the toppings, right? I just ate the part with the toppings. So if I eat it, is that adding or subtracting? We're subtracting, okay? So this is what we're doing. The area of the pizza slice, the whole slice, minus the area I ate so that I can get the crust. So everybody got that? Does that make sense? A little bit of visual for you to help you out. All right, so here we go. We got to start first with the entire slice. So we got to start with the entire slice. Okay. So what's the degree for that entire slice? 30. And then pi r squared. So we have to find the whole area first. And then we're going to do a big fat subtract. We're going to talk about this in a minute. This one is also going to be 30 because we're taking away this little part. So we're cutting out this. But the difference is going to be those R's. What is the radius of the big slice? From the center to the big circle outside. You have it on your paper. 6. So the big one is going to be 6. What's the little one going to be? Just the blue slice. 2. Okay, so I'm going to do those formulas and I'm going to write them down. All right, I'm going to start with this one. 30, and I'm going to leave it in terms of pi just because it makes it easier for me to work on. It makes it easier for me to work on, and then I'll put the pi in the end. So we're going to do 30 cross multiply. I'm only working on this part right now. So 30 times 6 squared. When we cross multiply, 360 times x is 360x. 30 times 6 squared is 1080 pi. And then we divide by 360, which gives us 3 pi. I'm going to leave it just like that because it's easier for me to look at. I don't need to worry about decimals. Everybody understand? All right. So then we're going to do this one. When I cross multiply, I get 360x equals, I'm doing 30 times 2 squared is 120. And make sure you put your pi on there. We're going to divide by 360. And I made it a fraction and did 1/3 pi. What do I have to do to these two? Subtract them. So now I'm going to do 3 pi minus 1/3 pi. And I'm going to put that straight in my calculator. 3 pi minus 1/3 pi. And I get the decimal, 8.377 or 8.4. So again, area of a sector and arc length are the same. The only difference is the bottom right. Okay. Any questions? All right. These are longer. Let's look at 13. Question 13. All right. We'll go back to number 12 in a minute. 13 says what value of h is needed to complete the square for the equation? You can do this a couple different ways, okay? This one, because you're given all the answers and all the stuff, there's another one that you don't have, okay? So I'm gonna show you this by hand so that we can do the other one as well, but I'm also gonna show you this one on Desmos. And I haven't opened Desmos up yet, but the way we would do it by hand, we're just trying to get it looking like this. So we're gonna complete the square. And that's where I put my blanks in, move that number over to the other side and put the blank on the other side. Does everybody remember doing this? Okay, they have a lot of these on there. Now this one, again, you can do Desmos, and I'm going to show you how to do it on Desmos because it's got everything you need. But if they give you a question where it's like, what is P of X minus G of X or something, it's going to be a little bit harder to use Desmos. All right, so how do I fill in this blank? 10 divided by 2 is 5, and then what do I do to it? Square it. So 25. I didn't pull anything out, so I just keep it 25. Rewrite it, the square root of the first sign, the square root of the last. And then 8 plus 25 is 33. And then we need to get it equal to 0 because see, there's where that minus 33 comes from. Okay. Now, be careful on this. Here's where they try to trick you. What does that say in there? It says minus H, right? But mine says what? How can I make this positive? What kind of number does it have to be in there? It has to be a negative. So it's going to be negative what? 5. Some of you will put 5 because you've got the 5 inside there, but you got to be careful of what it says. All right, so what if you do it on Desmos? Give me a minute so I can pull that up. We have x to the second. Let me put y equals in. Guys, I would just suggest that you put y equals in all the time. Plus 10x minus 8. And then you can fill in. We have x minus, and I would put it just like you see it, x minus, and then our first answer is negative 25 to the second minus 33. And again, nothing, I don't even see where my other one is. Does everybody see that? So then I'm going to go back and change it. The second answer was negative 5. Do you see what happened? So just be careful on that. Watch those signs. If I put in just positive 5, it flips it to the other side. So watch those signs. It's little things that I think that people get correct, but when they transfer their answers, it's wrong. Like you did the work right, but you put the wrong answer. Does that make sense? Okay. All right. Let's see. I don't want to do that one. I don't want to do that one. I don't want to do that one yet. We can do this one. Go to number 20. This one is actually pretty easy. This is more math 2 than it is math 3. It says triangle LMN and OPQ are shown below. What additional information is sufficient to show that LMN can be transformed and mapped onto OPQ? These triangles are obviously not congruent, correct? But they are similar, okay? What do triangles have to be, any shape, have to be similar? Congruent means what? Think back to math 2. What's equal? All the sides and all the angles, okay? Similar means that all the angles are the same, but the sides are in proportion, okay? What does proportion mean? What is a proportion? Give me an example. I don't care. Tell me you know what proportion is. What would be proportional? What's proportional? Do y'all know what a proportion is at all?
Something is bigger, like it's the same object, but it's bigger, and it's like 4 foot, and then the other version is smaller.
Right, and all the sides have to be in that, it's a fraction. It's a fraction. It either has to be 2 times as large or half as large or something like that. So everything's going to be the same. That's perfect. That's what I was getting at. All right. So when we look at this, to be in proportion, we have 12 and 8. So you would make that proportion like this, 12 over 8. If you wanted to reduce it, they both reduce by 4, which they're in a 3/2 or a 1.5. This one's 1.5 times smaller than the other one. Okay, so everybody understand that? All right, so the first thing is all the angles need to be the same. So the 55 is the same. Remember also in triangles, if 2 angles are the same, the third has to be the same. There, I got that. So if 2 angles are the same, the third has to be the same. So those are the things that you need to know for similar. So it says what additional information is sufficient. So the first thing that I want to look at are angles because the angles have to be the same. So I'm going to go there and just check those out. Angle LMN, follow it around, LMN, that one's 55, has to be congruent to QOP. That's this one. Is that the truth? No, they're not even the same position. So we know that that's not right. NLM, that's this angle right here, has to be congruent to QOP. It has to be. So this is going to be our answer, but I'm going to show you why the other 2 are not because we're about to do one with more proportions. So I want you to see the proportions as well. All right. It says that OQ has to be 6. So here's what happened. I did 12 over 8. So I did left over right, reduces to 3/2. If I do that for this one, I would do 10 over 6. When I reduce it, divide it by 2, I get 5/3. Is that the same as 3/2? So it would not be in proportions. Everybody see that? That's how your proportions work. So MN, they said MN would be 9. So I would set that up left over right, which is 9 over 4. I can't even reduce that. It is not 3/2, not in proportion. So the only one it could be are the angles. So for similar, angles the same, sides in proportion. Is everybody good? Pretty easy question. 21. Ta-da! Similar figures. What does that mean? What did I just tell you? Angles the same, sides are in proportion. All right, so let's look at the first one. I always do left over right because that's how I think. I read left to right, so that's what I do. So I'm going to start with 9 over 12. And then I'm going to see if it matches 6 over 9. You can do that by doing cross multiplication. What's 9 times 9? 81, and I just throw it up there. What's 12 times 6? 72. Remember, you have your calculator the whole time, so you don't have to do that in your head. Do those match? Nope, not similar. All right, check out the next one. Left over right. Just make sure you're using the same thing. So I'm using the height of this pyramid, 6 over 8. And then I'm using this bottom half of the base. Left over right is 2 over 4. Cross multiply, what's 6 times 4? 24. What's 8 times 2? Not the same. That's all you have to do. Similar figures are really easy. Proportions are really easy. Check out your next one. I'm going to use the outside and the bottom. So the outside is 5 over 4. But the bottom is 4 over 5. We can clearly tell that that is not the same. If we multiply, it's 25 and 16. Again, it doesn't matter. They just keep loading you down with all these numbers. Find the easiest ones. So the easiest ones for me are the ones on the outside that I don't have to get mixed up in all those lines. Okay. So left to right, we have 3 over 4. And then over here, we have 3 over 4. Definitely in proportion. (22) is a very easy problem. If you know what you're looking for. Okay, if you know what you're looking for. So it says the sum of a series can be calculated using this formula. So that's what we're going to use. What is the approximate value of the sum? But they just give you all these things. This is the sum. This is what we're looking for. So S of n is not a big deal. A1 is your first term of your sequence. R, and both R's are the same, is your rate. And then your N is the number of times that you're doing it. And all of that is in this series right here. So what's your first term? 8. Parenthesis 1 minus, what's your rate? You guys remember our formulas like PERT or A times 1 minus R to the T, those formulas? Your R is always found inside of parentheses. So this is your A1, this is your R, and this is your N. So your rate is always in parentheses because it's a multiplier. It's a percentage. So what's my R? Negative 1/7. I'm going to put it in parentheses. And that negative 1/7 is going to be raised to the what power? And just watch how you put it in your calculator. That 2,500 only goes with the 1/7. Okay. Over 1 minus, what was our rate? Negative 1/7. Okay, so we just have to be careful about how we put it into our calculator. I'm going to do this calculator, and I'm going to do alpha y equals so I can have a fraction. I'm going to type it in just like I typed it here. So 1 minus 1/7 in parentheses to the 2,500, get outside of that. It's exactly like I have it on my paper. And then on the bottom, 1 minus, and I'm going to put parentheses around this just because I do, but you don't necessarily have to. Ready? What I get? That's it. So not a hard question as long as you know what you're looking for. And then you type it into your calculator correctly. Again, things that they like to do is give you crap like this, and I don't mean that in a bad way. It's just hard to put in your calculator. You can do it, but you might slip up and mess something up on your calculator. So just be careful. All right, let's see what else we got. All right, let's look at number 23. I will tell y'all right now while I'm thinking about it, next Wednesday, your assignment is going to deal with awards day. Okay, you'll take a little break from math. And if we typically had awards day, and this is portrayed by Miss Hoover too, this is not Miss Jones doing this or making up a decision or whatever. If we were doing a normal awards day, you would be sitting in the gym for the first 2 periods of the day. Okay. So that's exactly what we're going to follow through. It'll be something to do with awards day. It'll be real quick. Got it? I promise. So Wednesday will be a real easy day for you. If you have anything you need to make up, that's a good day to make up some stuff. All right. The volume of a rectangular prism, volume of a rectangle box, is represented by the expression x cubed minus 2x squared minus 20x minus 24. If the length is x minus 6 and the height and width are equal, what is the width of the prism? So a lot of times this really screws you up. Just kind of reading it, just like, well, I don't even know what to do. So here's what I think about. When I do problems like this and I'm not sure what I'm doing, I make up my own. Okay, I make up my own. And here's how I do that. I'm going to make my box. And if you guys don't know how to draw a box, it's fine. All right. So the volume of a rectangular prism. So I'm looking for volume. How do I find volume of a rectangular prism? A box. Guys, you know how to do this. What's the volume of a box? Length times width times height. My Math 1 kids knew that. So I know you know that. All right. Length times width times height. So let's say that this volume is, I'm making up my own problem. This volume is 40. It's a random number. I don't care. The length is what they give me. So let's say they give me a length of 10. It don't matter what the length is, okay? You make up your own numbers. And then it tells me that the height and width are equal. So what does that mean? What's equal mean? Y'all, it's not a trick question. What does equal mean? They're the same, but we don't know them, so what can we do? Put an X for both of them, right? Since they're both the same. Good. So what you're telling me is if I do X times 10, I should get 40, right? Yeah. Well, how do I figure out what X is? It's not complicated. Answer the question. How do I figure out what X is? Guys, come on. This is Math 1. How do I solve this problem? Okay, I'm gonna multiply them together. So I get what? 10x squared, right? This is the step that I'm worried about. What do I do now? Oh, so you divide the volume by the length, right? Right? That's what you're gonna do in this problem. You're gonna divide the volume by the length. So we're gonna start there. We're gonna come back to this little problem I made. So how do I divide these two? I've already done it twice. So what? Synthetic, absolutely. What goes in my backwards box? Positive 6. I hope this is what you said. I can't really hear. I'm sorry. Okay. Masks. What goes across? 1. Negative 2. negative 20, negative 24. Okay. We bring down the 1, multiply it by the 6, add it up. 6 plus negative 2 is 4, times 6 is 24. Add it up, we get positive 4. Multiply it, we get 24. We should get a 0 because we know that it's going to work. Okay, it's linked, comes with, comes side, it should work. So we should get a remainder of 0. Well, how do I write this mess right here? How do I write this leftover step? Why do we do synthetic? Do you remember how to write it after that? Yep, hold on right there for just a second. We have x cubed. Remember when we divide, we take it down 1. So it's 1x squared, and you can put the 1 on there if you want to, it doesn't matter. And then we continually decrease our x's. So it's a plus 4, decrease the x by 1, plus 4, and the x is gone completely. All right, so you told me, I'm coming back to this problem. I divided by 10, and I got 4. Then what do I do? So square root, right? So how do I do that with this? How can I make this smaller? What could I do? Think about how you can make a trinomial smaller. So, what do you mean? Say it again. Say it again. I think you said it right. I just can't hear you. Sorry. Factor it. Factors of the last that add to the middle. What are your factors of 4 that add to 4? Remember when it said that those two were the same? Are they the same? Yes. So our answer is x plus 2. So again, not hard things. You just don't know quite what they're asking. Okay. All right. That's the end of this one. I don't want to do any other ones on this one right yet. I said I would go back to that one, but I did not. Let's see what we got on this one. Oh, number 1 is super easy. All right. Also a math 2 problem, but you don't have to have math 2 to know the answer. It's kind of common sense, okay? All right. So the math 2 is the term that they use in here. A board is made up of 9 squares. A certain number of pennies is placed in each square following a geometric sequence. You have 2 different types of sequence, arithmetic or arithmetic. I do either one. I say either one. I don't know which one you've heard. That means you just add every time. Okay, so you're just adding. Geometric means you're multiplying. Multiply. Okay, so know the difference between those 2. So it says a certain number of pennies is placed in each square. So I did a 3 by 3, so that makes my 9 squares. The first square has 1 penny, the second has 2, and the third has 4. Here's the problem. If you don't do it geometrically and you add, you're going to get the wrong number, right? So we need to think geometric. We need to think multiply. What am I multiplying here? 2. So what's the next box going to be? Next box. Keep going. Is everybody okay? What's it ask you though? How many pennies? So then we get our calculator. We add them. 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256. Any questions? Is everybody good? All right. Pretty simple. Here's one of those that I was telling you about. You have to do completing the square. We have to make it look like this, so we have to complete the square. But you can't plug in to Desmos because it gives you P and Q. Does everybody understand that? So this one only gives you the value of Q, so I can't plug in here. So I actually have to do it by hand. So we're going to take this, 2x squared minus 5x. They already have that number moved over, so I'm just going to add the blank. Sorry, add the blank. And then what's wrong with this side? Yeah, the 2. So I have to take out the 2. Now I keep everything in fractions because it's easier when you finish. So that's what I'm going to do. So we take out the 2. We have x squared minus 5/2 x plus blank equals -12 plus blank. Remember how we get this line right here, or this space, is we take 5/2 and we divide it by 2, right? And then we square it. I'm super lazy and I don't want to do that. So I'm going to put it in my calculator, and then I'm going to divide by 2, and then I'm going to square it, but then I'm going to turn it into a fraction. The reason that I do that is it's easier to take the square root. That's all. Now, remember how I get this blank is I multiply what I took out times what I put in. So times by 2, and we get 25/8. And again, it's all calculator active, so you don't have to worry about anything. But again, I would use fractions to make it a little bit easier for yourself. So the 2 is fine. I take the square root of the first sign, and when I square root a fraction, I do the top and the bottom. So the square root of 25 is 5. The square root of 16 is 4 squared. And then again, I'm lazy, so I'm going to use my calculator. Why not, since I have it? Change it into a decimal. We get -71/8. And we want it equal to 0 because that's what it says to do. So we're going to move the 71/8 over. It says, what's the value of Q? It's a plus. This is a plus. So that's my answer. Everybody got it? So we already knew how to complete the square because I already taught that a bunch of times. Then this one was crappy because I had fractions. That's the only way they make it harder. Any questions, number 3? All right. Don't like number 4. Don't like number 5. All right, we get number 8. We're almost done. The diameter of a circle. Every time I see stuff like this, I just automatically draw it. Okay. Diameter of a circle is 8 centimeters. A central angle, what does that mean? What's a central angle? It's common sense. It's at the center, right? So don't get freaked out about that. It's at the center. Inscribed is inside the circle. That means it's not through the center. Does everybody understand that? So those are your 2 different ones. So a central angle comes from the center. I don't know if this is right. I just make one, okay? It doesn't matter if I draw it to scale. It intercepts an arc. That means it's inside. Intercept is inside an arc of 12 centimeters. It wants to know the degree. All right, so how do we figure out the degree? What formula has used a degree, the diameter or the radius, and part of the arc or part of the outside, which would be the arc length? Has everybody got it? What was that arc length formula? What do we start with? Degree over 360. Remember, both your formulas start like that. Equal your arc length. And then the bottom is the one that messes up, or like changes, not messes up, but changes. So we want the arc, which means part of the outside. The outside could either be diameter pi, or I told you 2 pi r. It doesn't matter which formula you use, they're both the same. Okay. On this one, I'm going to use diameter pi because I have the diameter. So I'm lazy. I don't know my degree. That's what I'm looking for. Over 360. What was our arc length? Part of the outside of the circle was 12. Our diameter was 8 pi. We're going to cross multiply. And again, I'm going to leave it in terms of pi. So x times 8 pi equals 360 times 12. I'm going to divide by 8 pi, but again, I'm going to leave it in terms of pi. So I'm just going to divide by 8. And the reason I do this is because what's it ask you for? The radian measure. Right now we're in degrees. So how do we do that? Remember how we changed from degrees to radians or radians to degrees? It's either 180 over pi or pi over 180. This is why I leave it in terms of pi. I got to get it to cancel out. It's always wanting to cancel out. So if I have one on the bottom, how do I get it to cancel out? I need one where? On the top. So that means it's going to be pi over 180. So then those will cancel out. 540 over 180 is 3. So your answer is B. Okay. Radian measures will not always have pi in them. Okay. They will not always have pi in them. How did I know to switch it like that? Because remember, x is the degree over 360. So this was 540 over pi degrees. Now I need to change it. Got it? Is everybody good? All right, let's see what else I can do. I don't like that one. This one's easy. I think this one's easy. This is another trudge through problem. It says to completely cover a spherical ball, a ball company uses a total area of 36 square inches of material. What is the maximum volume the ball can have? So it tells you the surface area. So if we think about a baseball or a softball or anything like that, it's taking the cover off. That's the area that it's talking about. So the surface area. All right, sorry. And then it wants to know what's the volume. So we have to do both formulas. So the first thing it says is it has a total area of 36. There's your area formula. So the area is 36 of 4 pi r squared. How do I solve for r? Because to get the volume, I just need r. So that's what I'm trying to do, is solve for r. So how do I get that? How do I get r by itself? Divide 4 pi. You can go ahead and make this a decimal. It's not going to matter. Watch how you put it in your calculator. I'm going to put the 4 pi in parentheses like this because it's on the bottom. Or do alpha y equals so that it puts it on the bottom completely, okay? So this gives me 2.8647. I'm going to go a couple decimal places to help myself out. Then what do? Square root. On my calculator, I would do square root, go up and highlight that so I'm not having to type it in because, again, I'm super lazy. And then I get 1.6925. All right, so there's your radius that I can throw into my volume formula. So I'm going to do that in my calculator because, again, I'm too lazy to put all those numbers in. I'm just going to use the one in my calculator. So alpha y equals 4/3. I have pi. And then I have this number to the third. I'm too lazy to type it in. 20.31. Okay, well, I don't have a decimal on there. So how do I figure out which one's my answer? How do I figure out which one of these is my answer? Yeah, just type them in. Type them in. So we're going to try 27 pi. We got 84, so we know that's not right. 36 Square root pi is 63, that didn't work. 36 over the square root of pi, 20.31. 27 over pi is 8 something. What's up? Any questions? If it's a like fill in the blank kind of thing, like type in your answer, they'll accept either answer. Okay, so don't stress about it has to be in this form or it has to be in that form. All right. Let's keep looking. That's a really long problem. Let's go to 15. 15 is actually an easy problem. You just have to know what they're asking. Don't worry too much about vocabulary. Concentric circles mean like bullseye. Okay, they just get bigger and bigger and bigger. Okay, so concentric means there's a smaller one inside of a bigger one. Chord XY is tangent to the smaller circle. Tangent just means that it touches one point. The radius of the larger circle is 15 and the radius of the smaller circle is 12. So when you look at this and they give you that information, a lot of you will draw like a radius here and then you'll draw a radius there, but they want you to use that tangent line. So let's start this way. That's a radius of the smaller circle, right? That tangent line is going to help us. What did that make? What'd that make? Why would I draw it there? What would that make? A what? Say it loud. I just couldn't hear, but I think you said it right. What'd you say? Okay. So what's special about a T? Why would that be important to draw it like that? Come on, guys. Say it again. I'm sorry. Y'all are mumbly and behind masks, so it doesn't ever work. What's the point of making this? What's the point of making a T? What's special about a T in geometry? I don't know if they're the same length. What do they make when they come together? Not 180. You're close. 90. They make a 90-degree angle. Why is that important? Because then it tells you the radius of the larger circle. I can make that anywhere. And I'm going to make it right here. What did I just draw? A right triangle. Everybody got it? So what it also tells me is the small circle is 12. The large one is 15. It wants the length of chord XY. What we're going to get is this part. How do I find the full length after I finish? Times it by 2. Got it? How do I figure out that X? You always do it back. I do it the long way, you do it the short way, and that is perfect. That's how I would do it if I were taking the test. So I'm going to set up Pythagorean theorem. X squared plus 12 squared equals 15 squared. And the only reason I do it this way is to remind you that the 15 is the longest side. Make sure it's on the correct side. And then don't try to do this in your head, because a lot of you, and I've seen it even in honors, will do 15 minus 12 and then try to square that. That's not how this works. Okay. We're going to use our calculator. 15 squared minus 12 squared. And we get x squared equals 81. So then how do I find just x? Square root of 81 is 9. So this side is 9. That means this side is 9. So the full length is 18. Any questions? So again, once you find out what they're asking for or what you're supposed to do, it's a really easy question. All right, look at 16. What is the approximate length of the arc? Wonder what formula I would use to find length of an arc. Subtended by an angle of 4 pi over 3 radians on a circle with a radius of 6 meters. All right, so what's my formula for length of the arc? equals your arc length. I'll put arc length. Over what? One of two formulas. It doesn't matter which one you pick. 2 pi r is fine. This one gives us the radius, so 2 pi r will work well. All right, that's a 2. All right, the problem is they don't give us degrees. What do they give us? Radians. But I told you, what is the purpose of changing from radians to degrees? What are we trying to get rid of? The pi, right? So what would I multiply this one by to get rid of the pi? The 180 over pi. So your pi's will cancel out. Four thirds times 180, I want to make sure I do it right. Gives me 240 degrees. There we go. Now, if you did your unit circle, which I don't suggest that you do, that's pointless. At the 240, where you guys memorize the unit circle, would be the 4 pi over 3. So you would just have to, I wish they'd just give you the unit circle. That'd make it a lot easier. Okay. All right, so our degree is 240 over 360 equals, we don't know our arc length, 2 pi, our radius was 6. We're going to cross multiply, and they do not have it in terms of pi, so you can do decimals throughout. I just like to leave it in terms of pi till the very end. So I get 360 times x is 360x. 240 times 2 times 6 is 2880 pi. Divide that by 360. You get 8 pi. When I put that in my calculator, I get 25.13, so that I don't have to worry about rounding. That's the only reason I keep it in terms of pi, so I don't have to worry about rounding. Not too bad, right? Just got to know what they're asking for and how to switch it back and forth. All right. All right, we're going to stop there and be done. I'm going to go ahead and stop sharing and stop recording.